Welcome to the lesson video on generalized additive models. Generalized additive models are multivariate linear regression models where we're going to combine the nonlinear methods that we've seen earlier in previous videos in this module. And so in these generalized additive models, we have our output y, and then we have our intercept, and we're going to model this as a function of our multiple input variables, and each fj, right? These f's, they are different functions of the input variables, and each f can be one of the nonlinear functions we've talked about, or it can be just a coefficient, just a linear function. So we have the ability to model multivariate nonlinear functions, and we're going to have them be separate from each other, and then we're going to add the results from those separate nonlinear functions, and that gives us our additive models. Why do generalized additive models? We can better match the separate nonlinear relationships between y and individual input variables, but keeping the additive assumption keeps lower variance and increases interpretability of the models. So let's look at one example using natural splines. So in previous lesson videos, we've talked about just wage, age as a function of wage, and now we're looking at wage as a function of, well, the intercept, and then the year. I'm predicting a person's wage as a function of a number of different variables. And so year is the year in which this prediction is being done. And then we have the age of the individual, and then their amount of education, and then here's our epsilon, which is our irreducible error. So we see for year, we have a natural spline with 4 degrees of freedom. In age, we have a natural spline in 5 degrees of freedom. And then we look at education, that's going to be a step function, which makes sense. We have those discrete values. And then we can get a more accurate model using all 3 of these variables. Here's an example using smoothing splines. Using the smoothing splines, we have year and age. Again, they're 4 and 5 degrees of freedom. And then we continue to have our additive structure. And the advantage of this additive structure is we could say, by looking at this center plot, we could say if you hold the year constant and the person's education constant, then you can use this as a predictor, holding all the other variables constant. So that gives you greater inference, greater model interpretability using this additive structure. General additive models, pros and cons. And so here's a list of pros and cons. We're not going to go through and read each of them literally. They're in the textbook, Introduction to Statistical Learning. And the bottom line is these generalized additive models give us flexibility to match nonlinear relationships, but keeping the additivity doesn't give some control on the variance. It doesn't provide too much variance, contributing to increasing variance errors that occurs when you allow non-additive interactions. And it also, the additive structure allows us some level of model interpretability. And then the one drawback is that the GAMs may not be able to model interactions between our different variables. Other trade-off in the negative model, not listed here, but kind of a negative or a potential drawback. If your relationships are linear, then these nonlinear models will create variance errors. Right? It's harder to train a nonlinear model, and if it's linear, you'll get better results just using linear models. A little bit of advice here that I provided. Splines are generally good. Low-degree polynomials are generally good. Those are good things to start with if you're going to try to produce some GAM models. So review, we've looked at generalized additive models, or GAMs. What are they? They are linear. There are regression models where we assume the function is not necessarily linear, and we have a separate, possibly nonlinear function for each of our input variables. And why would you do this? It better matches the relationship between your inputs and outputs, but we also have to keep in mind that this increase in flexibility can lead to variance errors, and choosing those models is done generally with cross-validation. Thank you very much for watching.